Okay, I think we're everybody. So let me give you an introduction. So this is CUDAN Open Lab Seminar, as always happening on Monday between 2 and 4 Tallinn time, which is 6 a.m. Carnegie Mellon Pittsburgh time. And I'm very happy that Simon DeDeo made it to the computer screen, despite being brutally early today. And so basically the idea is, as always, to discuss one approach, what cultural analysis, cultural analytics, or whatever you want to call it, cultural data analytics is. And I'm very happy that Simon will speak today and discuss with us today. So the idea is to have a kind of 40-minute to 1 hour talk, and then in total we have a time slot of 2 hours, and the basic idea is discussion. Depending on the speaker, you can first give your talk and then we have a discussion. Last week we had a case where we sort of like had intermittent kind of 20-minute slots of speaking and discussion, which was also pretty interesting. So let me first give an introduction of like, who is Simon DeDeo? So I'm actually particularly fond of having Simon here as a speaker because his online profile is as ambiguous as my own. If you look up his affiliation, Simon is assistant professor in social and decision sciences at Carnegie Mellon University. If you just Google Simon, meaning you enter Simon DeDeo into Google, what then comes up is cognitive scientist. So that's your entry in the Google Knowledge Graph, which probably reflects the time of Freebase. I'm still in there as an archaeologist, which is probably as true as your cognitive scientist. Your PhD really is in astrophysics, right? If I'm correct. And you have been at the Santa Fe Institute for a very long time, which is one of the world centers for complexity science, which grew out of basically Los Alamos Lab under Murray Gell-Mann and a bunch of people who had a conspiracy going on. The complexity exists in many forms, not only in the explosion of nuclear bombs, and probably even more so in life and the rest of the universe, and particularly the brain and interaction in life and such things. And so basically now the idea is to analyze culture as a complex system. And without further ado, I would just hand it over to you. I could talk a little bit about what kind of papers you've done that put you on the map of cultural analytics, but maybe you want to introduce them yourself a little bit, because you've done some really groundbreaking work, but you also apply the same kind of approach to your own field of applied mathematics and physics, which is also very interesting. So the stage is yours.
Thanks. This is a very gracious introduction. It's lovely to be here, and I'm sorry I can't be there in person as well. I'm going to talk for as long as you guys will let me, but I'm very open to being interrupted, and you can put things in the chat if you like. You know, there's nothing I have to cover, and if we cover one slide and then have a discussion for 2 hours, I'd be thrilled. I'm going to talk about some theoretical ideas that we have in play here at Carnegie Mellon at the lab, and then I'll also talk about some work that some empirical work we've done. But it's really nice to be able to talk to CUDAN, to you guys out there in Estonia. It's hard not to notice that a lot of really interesting cultural analytics is happening over there right now. And it's kind of exciting to think that you guys are building a long-term research excellence in this field, and no one's really quite sure what it is, right? So it is indeed the case. My PhD is in astrophysics. And yet at the same time, it's not unusual for me to work with an anthropologist, with a historian, with a literary critic, with a psychologist. That kind of work is extraordinarily unusual in most disciplines. It's pretty common for us now, for those of us who want to study culture on a large scale. There's so many different things that you need to know or could know, or so many different approaches that you could take, that it's a new field, it's an exciting field, and it's also a field that has been traditionally difficult to support within the university system. So my first position was at Indiana, which was my first faculty position after the Santa Fe Institute was in Indiana, where I was in the computer science department. I'm now in a department that's split between psychology and economics. I could very well end up in a department that does political science, but I could very well end up back in a department that does complexity physics. So that means that what we do is often sort of hard to place. The fact that you guys out in Thailand are actually putting together something, a long-term home for us is very exciting, and it's a very hopeful thing for us. So I'm a Gen Xer, I'm a child of the 90s. So perhaps some of you are familiar with the X-Files, which is the screen, the thing I'm sharing right now. The X-Files is a reboot, is a show about two FBI agents. They're in like the shittiest division of the FBI, right? They're in the basement, and their job is to investigate paranormal phenomena. The plot itself, or at least the sort of driving character trait of Mulder, the man on the left, I'll just read this. This is from the Wikipedia description. We have Mulder's hopeful yet tortured conviction that the truth was out there, shrouded in conspiracy and waiting to be uncovered. So Mulder is the sort of conspiracy theorist of the pair. Mulder is the one who thinks that the government is hiding evidence of aliens, of paranormal phenomena. Scully is the skeptic. They battle each episode. What I would say is that we, as organisms, as human beings, are very much in Mulder's position day to day. That's both as creatures in the material world and also as members of social groups. The world is not transparent to us. The world is not transparent to reason. It's not something that one can simply do science on. The interfaces that we have with the world make it look simple, but in fact, most of what we do day to day, most of what we do in our lives, and that's on a small scale as well as a large scale, is seek explanations. We try to make sense of the world. And that's not an easy task. It's not a simple task. What I'm going to talk to you about today, or at least there's sort of two things I want you to take away from what I'm going to share with you today. The first is that explanation making, sense making, is everywhere. It's utterly pervasive. We spend very little of our time doing stuff and an enormous amount of time trying to make sense of everything around us. That's the first thing I'd like you to take away. The second is that explanation making, sense making, sometimes goes wrong. In fact, sometimes goes deeply, deeply wrong. And when it does go wrong, and this is really exciting, when it does go wrong, it sometimes goes wrong in systematic ways. There are systematic defects, systematic faults in the way we can make sense of this world, the world around us. And by identifying patterns across different failures of explanation, we may be able to make sense of some of the phenomena that we've seen or that we see today around us. And so those sense-making pathologies, those explanatory pathologies, the ways in which people try to make sense of the world and just fuck it up. So most obviously, those are conspiracy theories. They're people who believe bizarre and unexpected things about the world. Not bizarre and unexpected facts, but have instead, you might say, adopted bizarre and unexpected methods and tools for making sense of the world as a whole. So out here in the United States, we have QAnon, which I'll talk about, a conspiracy theory group that thinks that the United States President, Donald Trump, is engaged in a secret war that he can't tell us about against an elite network of pedophiles, right? This is as strange as it gets. But explanatory pathologies include, I would say, and you may agree with me, explanatory pathologies, sense-making pathologies, include things that are far more pervasive. So the other thing I'll talk about today is the explanatory pathology of sexism and misogyny, the way in which, as cultures, we make sense of the world in ways that systematically portray women as incompetent or unable to reason or have agency. So these kinds of failures of sense making on the surface, or like when you sort of look at failures of sense making, pathological explanations on the surface, they look really different from what we hope you and I do every day when we wake up in the morning. Our work suggests that the surface level distinctions, right? The fact that people who have conspiracy theoretic beliefs, for example, are usually incredibly anti-Semitic, right? Those surface level distinctions are a distraction for us. In fact, conspiracy theories are on a continuum with healthy epistemic practices. We can't understand the cancer of explanation until we understand how it's part of a healthy explanatory process that goes wrong. So I'm going to talk today about how explanation making works. I'm going to talk in particular about how it goes wrong in groups. And if you're sort of awake, I should say, if I'm awake, I'm still awake. If you're awake at the end, we'll get to some real in-depth examinations of how conspiracy theories work in online behavior. Any questions?
Yes, I have a question.
Yes, thanks.
I wonder, because you started with some preview about gender stereotypes and so on.
Mm-hmm.
My impression is that kind of conspiracy theories is mostly widespread among male population. Do you have any comments about it?
Right. So a couple things. So when I use the term conspiracy theory, this is a bit of a catch-all term. So technically, if you go into the sociological literature, in order for something to be a conspiracy theory, it has to posit the existence of a small group of people acting in secret for nefarious purposes to influence major world events. So that's the sort of technical definition of what a conspiracy theory is. And it's very useful to have that technical definition. So you could say, okay, yes, conspiracy theory, not. In fact, we're interested in explanatory pathologies more generally. So there are ways of viewing the world, systematic explanations of the world that you and I would consider kind of so screwed up and weird that we want to put them in a certain class. They may or may not rise to the level of a conspiracy theory, meaning they may not meet all those criteria. In fact, in order to deal with this issue, we ended up coming up with a term. We called them epistemic counter communities. So there are kind of bizarre beliefs and ways that people organize how they make sense of the world that don't quite meet all those characteristics. Now, the people who tend to meet all of those characteristics, who believe that there's a secret cabal acting nefariously to influence world events, that group tends to be a particular kind of person. I actually don't know the gender breakdown. It's a good question. But for example, if you have paranoid schizophrenia, you're going to fall into this group. You're more likely to fall into this group. But there are also sort of larger scale pathologies that don't quite rise to them. And I'll have one example. But if you organize your view of the world, let's say, around the idea that women, even though they appear to be just as, sort of intellectually capable or whatever as men, if women are actually secretly not quite human, you organize your view of the world around this belief. That may not rise to a conspiracy theory, or that may not have all of the criteria necessary for a conspiracy theory. Dennis, I'm somewhat speaking around your question. One of the things you've raised here is the importance of definitions when we come to study social phenomena, and I think that's probably what you've triggered in me. Is that speaking to your concerns at all, though?
Somewhat does and somewhat doesn't. You showed the example of X-Files,
Yes.
And the ways that protagonists are divided is exactly based on kind of gender stereotypes, right? That Mulder is male and he's the believer believer of this, and Scully is female and she's not the believer. So like in the popular culture, usually males are presented as crackpots. I don't know whether it's like a sociologically valid observation or not.
Yeah. I see what you're saying.
Yeah, so do you have, can you,
I'm not sure. I think it's, with these kind of hot button issues, I think it's a little tricky. So it's certainly the case that, one of the groups that we'll study, that I'll talk about today, will have, they'll be, it's a group of men. So if I can be sort of non-scientific for a moment, if you have bizarre beliefs, you often do strange things. If you're in a position of power in society, it's more likely that the strange things you believe will impact other people. And so we may be predisposed to notice conspiracy type thinking, sort of sense-making failures, explanatory failures among men, simply because men cause more trouble when they believe bizarre things. The sociology of conspiracy theories, like the gender distinctions of them, I don't know about. You're right, of course, that in the Mulder-Scully case, like Mulder is the guy, he's got these strange sort of systematic views about the world. Scully is the one who's sort of operating against him. I would say the flip side is that if you asked for gender stereotypes in the real world, you would probably get most people telling you that women, for example, were more superstitious than men. Now, I don't know what the actual gender divide on that is. So maybe the right answer is to say that our intuitions about which groups are more or less susceptible to explanatory pathologies, those intuitions may not be accurate. So maybe I can return to that a little bit when we look at one of the examples.
May I say something? So obviously, Simon, you got a paper which is on the Old Bailey and the civilization of language in the basically British Supreme Court about 200 years. Yes. And one of the interesting things is obviously the, in Great Britain, witches were burnt still at the same time when, there was gas lights and crystal palaces and mass transportation around. Right. So one could probably find examples in both directions. So I think we should leave it as a question. It's a really interesting question. Yeah. But yes, I think it's something I'm reminded of that paper because basically you already sort of like have one example where you have at least not the quantification, but some quantification of the phenomenon in essence, right? So yeah, no, I think that's, yeah. One of the things that I think this is bringing up is the importance of coming up with clear definitions of what we mean when we want to talk about explanatory pathologies, right? Without clear definitions, I think we rely perhaps a little bit too much on highly visible examples of whatever we're interested in. One of the things, and again, I mentioned this just briefly before, a lot of the kinds of strange forms of explanation making going wrong that we see don't quite meet the technical definitions for conspiracy theory. So take astrology, right? If you organize your life around the idea that the stars are predictive of the events that are going to happen that day, that the stars are predictive of your relationships, of your personality, the personality of others. You organize your life around that. It doesn't meet, for the sociologist, that doesn't meet the technical criterion for a conspiracy theory. And yet we do want to somehow say something is going wrong for this person in a way that may be related to, the person who has a sort of large-scale belief in alien visitation or, the Jewish world conspiracy. But if we don't have sort of clear dividing lines, or at least in some ways, some kind of in and out categorization, if we rely on our intuitions, we often end up relying a little bit on our prejudices. One of the jokes, so one of the groups we'll talk about is they organize their beliefs around evolutionary psychology.
someone had the joke, evolutionary psychology is astrology for boys, right? It's a sort of belief system that has a lot of the same functions that astrology does, except it also looks a little scientific. So again, like kind of coming up with sort of clear definition about what we're trying to study. I think it's a real frontier. I mean, I usually hate review papers that define things, but this may actually be a case where we want to do that. So let me think here. I'm just given where this conversation's going, I'm going to talk a little bit. I'm going to show you just a few slides from here. Let me just introduce this, and I should say this morning. I was writing this last night. I'm going to talk about two things here for us. I'm going to give a little bit of a large-scale framework, so of how I think contemporary computer science allied with the kind of big picture visions that I think you guys have in Estonia, how these are producing a new kind of science. And I think many of us are thinking about not just the questions we have in place. I'm really interested in right now in questions of sense making, of explanation making, and culture, how people explain things, cultures of explaining. But I'm going to talk a little bit about the even broader picture story. How do we, what kind of frameworks do we have to explain culture? And this is something that is becoming more and more clear to me as I start teaching seminars, as I lecture to graduate students. It's become clear to me that, Max and I maybe, we do our work a little bit on gut, right? We just could have we're like pigs in shit, right? There's so many cool things to work on. We just jump in. But I would say it's really worth thinking about large scale frameworks that we can see being applied across different questions, across different disciplines. So I'm going to talk a little bit about my view of that, which I call Bayesian cultural evolution. It's a way to extend an enormously successful project we've had in cognitive science to the large-scale social domain, to the study of large archives, and to the study of cultural evolution itself. So I'll introduce that. That'll be maybe about 10 minutes. And then I'll talk about some of the stuff that I introduced here, right? What I think of this, our work on explanation making is really the emergence of what I would call epistemic meta norms. So epistemic meaning knowledge formation, right? We have epistemic norms, so there's things we ought to believe. So like Max and I, we probably, have pretty strong views about how to do statistics, right? We think, okay, like p-value is probably not so great, right? We have views about, the ways in which causation works in culture. There are things in other words we believe, and indeed we believe them normatively in the sense that we think people ought to believe them. Sitting sort of behind those things that Max and I believe are what you might think of as meta norms. Norms for how we change our beliefs, norms for how we go about forming our beliefs. So Max and I, for example, probably have strong norms around the scientific method. We have norms around falsifiability. So you believe X, but in fact, more importantly, you have sort of high-level beliefs about how to go about figuring out whether or not to believe X. So something like, let's say, falsifiability. One of the things that we see in our work is that these meta norms, these rules for how explanations get made, the rules for how we think those get made, those meta norms themselves are under evolution. So that's the story we're going to tell about, in fact, not just the emergence of conspiracy theories, but also the history of science. So I'll talk about work, some theoretical work with a graduate student here at Carnegie Mellon, Zach, who's done some stuff on Bayesian models of explanatory values. I'll talk about work that Gabe and Will have done in the lab. This is work in the history of science. So Gabe and Will's work, in some sense, gives us the first empirical view into the evolution of sense making and explanation making. In this case, you might think of it as like explanation making gone awesomely well. It's the emergence of large scale scientific practice. And then finally, right, if you're good, we'll talk about one of the big conspiracy groups or sort of counter-normative epistemic groups that we've studied. This is work by Chloe Perry. Chloe's now a PhD in American Studies at the University of Michigan. She was at the lab with us for 2 years. So Chloe's work focuses on not explanations gone right, but explanations gone wrong, pathologies of explanation making, and in particular, what she calls the manosphere, a sort of large-scale network of blogs and discussion groups that center around a particular kind of sexist explanation making, stories about what men are, stories about what women are, that men sign on to en masse in the hundreds of thousands, even the millions, that order and structure their view of the world. So Chloe is, these aren't quite conspiracy theory groups. They're rather communities of sense making, you might say, that organize young men around a set of unusually toxic, unusually strange from the outside views about the nature of men and women. So those are the two chunks. Max, I should say, is this a good pattern here? What I'll do is I'll do some big theory first, and then I'll do some empirical stuff.
Yeah, that's great. That's great.
Great, excellent. Thank you. So yeah, this is a wonderful opportunity for me. I will say, just as a meta point, you know, the chance to actually, instead of, I mean, I think Max has this feeling too. A lot of the work we do has some pretty flashy outcomes, and so you know, we're kind of used to showing off our work to other people. This is a really nice opportunity for us to dig into some of the deeper theoretical questions, some of the deeper questions about how we as scientists do this kind of work. So I'm going to jump right into basic cultural evolution. I should say all of these folks are at the Lab for Social Minds. We're funded by some really generous people, and then some not so generous people like the US government. Among the generous people, I will say, is a guy called Jan Tallinn, who is in Estonia. He's one of the co-founders of Skype. So Jan has been a supporter of this work for a while, which is wonderful. So sort of a double thanks to Estonia right now and to Tallinn. First question is, why cultural evolution? Why should we study culture? Why should we study the arts? Why should we study the sciences? Why should we study human practices with a framework drawn from biology? Well, I would say, and maybe this is the simplest way to say it, this is, you know, one of the great paper titles of all time. Nothing in biology makes sense except in the light of evolution, right? So there is nothing that we see as a biological phenomenon that we can understand until we understand the fact that it evolved, meaning that it evolved without top-down design, that it evolved blindly in some important sense, and we'll sort of figure out what blind means in a moment, and that it evolved through a process of variation and selection where the ways in which variation happened were not directly connected to the organism's function. So the same is true in culture, I would say. The same is true in the study of culture. Dobzhansky was not wrong. He was writing well before, I think, we understood the enormous complexity of the biological organism. What you're seeing on the screen here is a metabolic network. So this is how in biology organisms get energy out of a carbohydrate and into their internal processes. This is not how you would design a biochemical reaction if you were an engineer. This is the structural properties of how a biological organism gets energy into its cells is very different from the ways in which Elon Musk will design a solar panel. It's not just that the organism has different constraints from the engineer, but the very design process that the organism has looks different, right? So you can dig into this over and over. What biologists realize is that evolution is not just a fairy tale that helps you sort of explain to, like some kind of religious person why you don't need God to explain the biosphere. Understanding evolution is also critical for making sense of the things we have right now. If in order to understand the organization of a biological network, you have to understand that it's the product of a certain kind of variation and selection. Here's another way into this. Here's another way to see this. We understood, I would say, the power of evolution and the strangeness of it better when we started applying evolutionary algorithms to the design of things we previously engineered. So this is a great example. I learned this from David Krakow at the Santa Fe Institute. So NASA builds satellites all the time. They send things up into space. Satellites are complicated. There's many different moving parts, and hopefully they don't move too much. But one of the moving parts is the antenna. So every satellite needs an antenna to communicate with Earth. The design of that antenna is critical. You want to make an antenna that's particularly good at receiving the signals at the wavelengths and the frequencies that the ground control expects to send at. That antenna has to be designed as well to deal with the local interference that's produced by the rest of the spacecraft. So antenna design is a constant part of satellite design. Usually the way people design antennas is by simulating the electromagnetic environment, thinking hard about what kind of pattern you need, how the antenna should be physically put together. In a sense, you might say teleologically designing the system. They have a problem, how to pick up a frequency. They think about the ways in which they could configure that antenna according to a set of schema and then build one. Well, these guys, instead of building the antenna, instead of designing the antenna in a top-down form, what they did was build an evolutionary algorithm. They simulated the antenna as in fact a population of little antenna organisms that lived or died depending upon how well they were picking up the signal. You know, sometimes these antennae could have sex with each other. Who knows exactly what they did? But in the end, here's the antenna that they produced. So, I mean, I think the right way to look at this, right, is this looks like a bogus made-up object. This does not look like a designed thing, right? It's like, it does not look like the antennas that you see on top of a building. It certainly didn't look like any of the antennas that engineers had designed previously when they were working as engineers, as opposed to, in this case, biologists, right? If you look at this as somebody, as somebody used to top-down design, it looks utterly mysterious to you. But I would say that this is not only the situation biologists are in, right? It's also the situation that we as people studying culture are in. When we look at a cultural phenomenon, we're looking at something that was not designed. Even if some of the participants in that system think they're designing something, right? They're not actually designing it in the ways that an engineer designs an antenna. They're much more in the situation, the objects that we're seeing are much more like this kind of strange evolved antenna than any kind of antenna built for purpose by an engineer. So the underlying challenge then for us is, if we make this analogy, is we're going to say that, okay, cultural practices, cultural phenomena, the things we see in large-scale data sets, are sort of like the phenotypes of a biological system. So phenotype, just a technical word. Phenotype of a plant means literally the properties of the plant or the properties of the organism that are visible to us and that affect its survival, right? So in biology, we attempt to understand or make sense of phenotypic variation. Hopefully the sort of brief introduction I've given you here suggests that understanding phenotypic variation is not easy, that the ways in which a plant, for example, looks to us don't directly correspond to the ways in which an engineer might have designed that plant, right? In order to understand the plant's design, we have to understand it as the product of evolution. But the other thing that is sitting in here that we, I think, pay less attention to and that we ought to, as scientists, understand better, is the fact that the plant, in order for phenotypic variation to transmit itself from generation to generation to generation, in order for phenotypic variation to happen, all of the information necessary to copy that organism from one generation to the next has to pass through a bottleneck, right? A plant doesn't get up onto a 3D printer and make a copy of itself. Instead, all of the information necessary in order to transmit the data to get that plant out the other side passes through what we can think of as a genetic bottleneck. So all the complexity of the plant, all of the information that we see on the surface, everything that we want to describe about that plant, in order for that to persist from one generation to the next, the plant somehow has to be able to encode it algorithmically in the DNA That DNA is a tiny, extraordinarily constrictive pathway to get to the next generation, right? You yourselves do the same thing, right? You are an extraordinarily complex person. There are many, many features of you, right, that would take eons to describe. But when you, if you so choose, right, when you produce a child, right, all of that information is crammed into a tiny, tiny subset of your body, half your chromosomes in a sexual cell, right? All that passes through this extraordinarily tight, constrictive stage. Now, as biologists, right, biologists understand this today. We understand that we can't do evolution until we understand molecular biology. We can't truly understand the ways in which plants evolve, flowers evolve, until we understand the biological mechanisms by which that information is transmitted from generation to generation. The same thing is true in culture, right? A cultural practice, a way of doing things, an art form, a genre, a way of conducting trials in the Old Bailey. Thanks, Max, for reminding me of one of our first big papers, right? Any cultural practice has to pass through a bottleneck parallel to the biological genetic bottleneck. That bottleneck is the cognitive bottleneck, right? A painting doesn't get up on a photocopier and copy itself, right? In order for a painting practice to be transmitted to the next generation, it has to be observed and understood by a person. It has to get somehow into that person's head. And the way that practice appears at the next generation is that that person then reproduces it from what sits inside their head. And of course, all of the activities, all of the sort of the scaffolding that exists around them. I think this is a crucial feature of cultural evolution that we've neglected. What's exciting is that it makes the social sciences and the psychological sciences much closer than we've ever seen them before. We have a little bit of this. We can see some economists thinking this way. They try to understand macroeconomic phenomena by reference to microeconomic psychological phenomena. John Maynard Keynes was one of the first to do that. But it's something that's sort of somewhat disappeared from our traditions. We've somewhat isolated, we've segregated the cognitive sciences from the social sciences. But in a sense, the cognitive sciences serve the role of molecular biology for cultural evolution. Any questions about this parallel here?
Maybe you could, so obviously one major thing which resonates in the background is this idea of the two worlds, right? And typically this is between the humanities and the natural sciences, but you're actually opening a separate frontier, which is, you know, if you stay within economics, it's macro versus microeconomics.
Yep.
And so maybe you can talk a little bit about, because there is a similar beef going on as against evolutionary psychology with macroeconomics, right? That there's this, our economy runs on macroeconomics, and that's also why 2008 happened. I'm not an economist, so I can make that kind of conspiracy theory-like statement, but so the key thing is, like, maybe you can thank you for mentioning Keynes, but maybe you can sort of like explain us a little bit more why we shouldn't do or rely on macroeconomics in order to understand culture, which basically also means we throw out the kind of linear regressions and all that stuff, right?
So, I mean, some of my best friends do linear regression. Let me, and actually, I don't really know the composition of CUDAN. I mean, how many people are in the humanities over there? How many people are in this sort of, think of themselves as STEM or ex-STEM people? But, when I studied literature, and I still do, although I'm not getting paid for it these days, there was a big opposition between the people who did close reading and the people who wanted to talk about literature as a social phenomenon, right? So, there were, for example, two ways to study queer literature. You could study, and this, like, let's say, how did Oscar Wilde, write about being gay? You could study the particular microstructure of a poem, the particular arc of a poet's life. You could look at a single object in enormous detail. And so these are people who did what we called close readings of literary objects. And I'm perhaps belaboring this for you, Max, but you know, this is, I think it's worth getting clear on for people, right? So one thing is you pay a great deal of attention to an object. On the other extreme, right, you take this kind of synoptic 10,000, 30,000 foot view, right? So Franco Moretti talked about distant reading. We've been doing distant reading for generations in the humanities, right? There have always been historians, cultural historians, literary critics who have looked not at single objects, but at large scale patterns and tried to tell a story about the large scale, let's say, the decline and fall of the Roman Empire. So we've had the macro-micro distinction in the humanities themselves. We didn't need the scientists to cause this problem for us, right? We've already had this sitting in there. So for me, I think what's exciting about the kind of data science era of culture analytics is that we're actually required to work at both these levels, or at least we get the opportunity to work at both these levels. We certainly work at the 30,000 foot level. We certainly look down from a great height with a database of 5,000 documents or 50,000 online posts. Chloe's data goes into the millions, right? There's no way we can read all of those things. Our Old Bailey data was on the order of 250,000 documents. So we certainly work at the macro level. You might say we look at shifting macro indicators, right? This paper that Max, you and I were kind of dinging back and forth about, where these guys talking about like, oh, do facial expressions look more trusting over time, right? That's a kind of macro approach where we look at, we operationalize culture in this way or that way and look for large scale trends. So that's, that would be equivalent for an economist looking at inflation variables, looking at interest rates, looking at unemployment data. But I think the exciting thing we have is the possibility of making sense of the shifts in the macro variables by reference to micro variables, by reference to the individual level experience of one of those documents. Okay? So the reason that culture has the phenomena, the macro phenomena it does, is in part because, and I'll put this up, right, the the cognitive biases that exist inside the human mind, right? In the end, humans make culture. So we can study the shifts of macro variables. We can study, we can measure the average number of, like the average word length in a, in a sentence and see how it shifts over time. Great project by Dennis Tannen, literary critic at Columbia, looked at the evolution of what he called clutter in 19th century novels, right? So 19th century novels, at some point they start talking about all the stuff in people's houses. So he can track this wonderful macro variable, right? The sort of density of clutter in novels over time. That's the macro level. But we can also, at the same time as we track the macro variable, because we have the resolution, we can also look at the individual text, right? And we can also say, okay, what is the experience of reading a novel that's full of clutter, right? How is that represented in the human mind? And it's represented this way or that way. That will influence how that person then goes and themselves writes a novel, let's say, or what they expect, what they celebrate in the novels that come next. So I think this is an exciting moment for us that we can actually do both potentially. Is that speaking to your concern, Max?
How should I say that? Yeah, it is in some sense. The key thing is, like, I'm coming from Germany, right? And so the weird thing about the two worlds is it's not only the micro-macro thing, but the thing that between Geistes- and Naturwissenschaften it swings with it is there seems to be this residue difference between nature in natural sciences and Geist, which basically means both spirit and mind. So on the one hand, you could say, and we would probably be on board with that, to say, okay, there's many different representations of the world, even though we would assume there is one real world, which we ideally could make a physics of. There's many different physicists who think about the world in different ways. Right. That would be sort of mind versus nature, right? Yep. But obviously, the spirit versus nature thing sort of would assume that the humanities are different from nature, which in the last consequence would also mean that animals and humans belong to different realms, and we are, nice.
I mean, right. This is the question, right? How do you have a science of spirit, right?
Yeah.
And I think this is great. I mean, you know, obviously as a sort of, you know, like we have a neo-Hegelian tradition here in Pittsburgh, right? I'm a pragmatist. It is, I would say it is certainly possible, right, to talk about patterns, biases, certain reliable phenomena that you see repeatedly in different domains. And, you know, if we get to some of the empirical work, we'll have that hopefully. That we will see that it is possible at least to identify regularities in the evolution, let's say, of spirit, right? Because that's what we're really after here. The macroevolutionary things that we're tracking, you know, the amount of clutter in a 19th century novel, the average sentiment of a gaze in a painting, those macro variables, you know, we're not directly interested in those. I mean, they themselves are obviously beautiful phenomena. We're interested in studying them simply because we like to go to the art museum. But really what we think they're doing is providing us symptoms of what may be, in the end, underlying laws for cultural evolution and for the evolution of spirit, right? So is it possible to have a science of spirit that's like a natural science? I would say, well, look, there's a deep philosophical question. I would say yes. I mean, obviously, you know, our friend Hegel, right, has a certain account that he wants to give that makes the science of spirit fundamentally different, and fundamentally, I would say, recursive, right? So what's important for him is at some point the history of mankind becomes a history of its own reflection. It becomes a history of its self-reflecting upon itself. That is a totally different kind of thing that, you know, when Hegel was writing, we just didn't, like, nobody had really, you know, thought about that or considered that. I think we can actually have a scientific account of recursive thinking. I think that's something that indeed we'll see it. Like the very idea that meta-norms are themselves evolving over time is something I think that would be very sympathetic to Hegel's project. Okay. I'm using Hegel here as a placeholder for, like, you know, someone who's not an idiot, who's trying to make sense of culture, and who had done so in a way that at least potentially could be applied to, could benefit from a quantitative scientific perspective.
Interesting. So Pia Tika is raising her hand as well.
Please, yeah.
Yes, very interesting discussion. I jumped in a little late. Sorry. I definitely really a lot like this idea of macro and micro worlds together. Those focuses. Especially, I would like to return to that cognitive bottleneck that you mentioned, because it's very close to my own project. So in some sense, as I understood that you were saying, everything basically that human research, I mean, we researchers as humans, when we, whatever data system, data analysis method we use, whatever is our focus, is it a large macroscope, or is it a macroscope or microscope?
Yes.
It all goes through our cognitive bottleneck and how we as humans in a certain point of the time see and understand these topics. So do I have a question? I don't know, I just wanted to reflect a little bit more of this cognitive bottleneck that you mentioned.
Yeah, I mean, like, some of my thinking on this, and perhaps the reason I'm belaboring this was because I had to start teaching it in my seminar. You know, look, I have a bunch of ideas. I have a bunch of thoughts, right? I'm trying to get them into your head, right? I'm talking a great deal. I'm going to talk for a long time here. You guys are never going to say, you're never going to repeat any sentence that I say in this talk, right? Almost every sentence longer than, I would say, 4 or 5 words is practically unique. When you hit a sentence longer than that, of 6 words, it's over. You will never say the same 6-word sentence again unless you're an actor. And yet at the same time, right? So on the surface, right, there is zero fidelity of transmission, right? if the thing we should care about is the surface phenomena of culture, there is no evolution, right? It'd be like, hey, like you guys, did you like spread your meme to Estonia? Well, on the surface level, no, right? Because I guarantee none of you will say any sentence that I just said, right? None of you will repeat anything I said. Maybe you will use the word cognitive bottleneck, maybe, like 2 words, right? But that's, I would say, the wrong place to measure these things. It's the wrong place to study them, right? The fidelity of replication, which is crucial to biology, right? If children didn't look like their parents, there would be no evolution. And yet at the same time, when I talk and when you talk, there's no overlap, and yet somehow we want to use the cultural evolution paradigm. What's going on? Well, what you have to do, and this will come in a moment, right? What you have to do is understand that I am potentially transmitting ideas to you. I transmit ideas, right? The ideas are in some sense invisible. They're latent variables, right? They're latent representational structures. What you see and what's in our data are all the surface phenomena, right? So part of the challenge for us is understanding the relationship between these latent variables, the surface phenomena, because it's the latent variables, it's the representations of the world that get transmitted, and how that works is going to turn out to be really bizarre. So let me get to that, and then we can, I think, return. What I'm going to do, in other words, is kind of tease out a little bit more what this cognitive bottleneck is, because it actually it is a bottleneck. So there's something shared between biology and culture, which is the fact that the richness of the world gets crunched down really tightly before getting re-expanded. We're constantly, it's like the JPEG, right? You take the screenshot, you save it, somebody else puts it on their screen, takes a screenshot, right? There's a similarity there, but there's going to be some very interesting differences. So let's move on, and then we'll take this up again. But I'm pleased this word resonated for you. So this is a book. Joel Mocher is an economic historian. I think it's very useful to there's lots of introductions to cultural evolution. If you want to dig into this further, I'd really recommend this book. Joel is great because he's an economist, but don't hold that against him. Joel is somebody trying to explain or make sense of the Industrial Revolution, and particularly the Industrial Revolution in the United Kingdom, which is a great puzzle in economic history. This book is, half of it is just wonderful qualitative history. So looking at the ways and like the lived experience of an entrepreneur in 19th century Britain, 18th century Britain. But the other half of it is articulating a framework that's familiar to cultural historians, but doing it for the purposes of making sense of entrepreneurial culture. So this is a great book to look at if you have a more if you're a text person as opposed to a numbers person. Joel talks about all the different ways in which the cognitive bottleneck, he doesn't call it that, but the cognitive bottleneck affects the practices, in his case, of engineering innovation. He talks about different biases, which I would say kind of cohere around what in behavioral economics we would refer to as the suite of cognitive biases. Just as a thought, if you're a science fiction person, so I said you can read Joel's book if you want to get a kind of a historian's view, economic historian's view on cultural evolution. If you're a science fiction buff, I would highly recommend reading David Brin's book, Existence. This came out a few years ago. Brin's one of these nerds, he's a very hard sci-fi writer, but Brin's book is wonderful. This is a book that centers entirely around cultural evolution. So I think we're used to the fact that biological evolution is extraordinarily powerful, right? Biology made us. We are unbelievably awesome robots, you might say. Still, we cannot build a camera that in any way approaches the dynamic resolution of the human eye. Like, there's something incredibly powerful about biology and its ability to make complex, robust systems. David Brin's book is about cultural evolution, and the plot is continually, over and over again, it sort of shocks you with the potential power of how cultural evolution works. So, 2 things here. One is cultural evolution is a paradigm. There's some good places to learn about that in greater detail. And I would say, do not underestimate the power, right, of evolution to produce unexpected phenomena. One thing worth thinking about is if you allow this cultural evolution metaphor to go through, right, if you allow the idea that the way complexity emerges in a system is through an evolutionary process, we think in terms of, for example, generations, right? We're in a remarkable point in history, because cultural evolution, at this moment, because of communications technology, cultural evolution has sped up by an enormous factor. So I grew up in the 90s, as I mentioned, with my reference to the X-Files. I used to read Wired magazine, right? But I read Wired magazine before we had the internet, or before I had access to the internet. So if you think about the sort of generation time scale here, right? I read Wired magazine, William Gibson writes an article, I read it, it goes into my head, right? It sort of does something to me. I think about it, I write, let's say, a letter to the editor, I send it into Wired, they maybe publish it the next month, right? If everything goes to plan, right? So the generation time scale from Phenotype, William Gibson's article, goes through my brain, comes out the other side to new Phenotype, right? Simon DeDeo's letter to the editor. That time scale is about a month, right? And that time scale has been ever basically since the modern postal system. That's roughly the time scale of culture, right? Maybe a week, right? Maybe a month, but certainly not what we have today, which is minutes, right? So if it took a month for a generation to go from the cultural phenomenon to a new cultural phenomenon, and in some sense it's the child of that one, in the current era, it takes a minute. So I read an article online, I read it on Reddit, I read it on Twitter, whatever it is, I can respond within seconds. I can produce a responding phenotype at an acceleration factor of about 40,000, right? So if, imagine if humans, instead of reproducing once a month, they reproduce once a minute, some kind of bacterium speeds up like that. If you'd sped up biological evolution by the same factor of 40,000, we would go from dinosaurs to mammals in 100 years. This acceleration has kicked in basically since, people like Mark Zuckerberg worked out the modern social media ecosystem. So this happened about 10 years ago. We've sped that up. We've done that 4 potentially orders of magnitude faster. Literally maybe 2010, 2005 at the earliest. We have no idea what's going to happen next. If you believe cultural evolution is the right framework, we've sped up history by this amount, right? The generation time is the ticking of the clock. So how do we make... Yes, go ahead, please.
Yeah, so to both prove your point and disprove it. Yes. So here's my speedy reaction to what you just said. Yeah. Now I'm going to disprove it. So obviously the time of thinking didn't change, right? So now you get 150,000 comments that all sort of come with some preconceived answer to something that sort of is triggered or tickled in the lizard's brain, while it may still take you the month, or let's say the 2 weeks or the week, to respond to the William Gibson article in the same way. And now the key question is, how do you actually deliver that? Because it's not going through the filter mechanism is different. The cognitive process is the same. It's just the speed of publication that is sort of sped up. But the filter process is different. Like, people look immediately and they're not interested anymore in the same topic in a month when you're ready to deliver your answer. And so that's a major pathology I think we have going on. Like, there is many Sleeping Beauty articles one could mention to computational social scientists, where you simply have no moment when you want to answer that, because if you just tweet it out, people are going to be, they're going to be adverse, but it's not published somewhere, right? And so the key thing is, the time of thinking is still the same. And what really only sped up is the publication. And so how do we deal with that? Like, I think it's not as simple as you outline it, even though it is a quite attractive way of putting it, right? Isn't it?
Right. So, I mean, what I'm trying to get people to do is think about, what does cultural evolution tell us the relevant timescales are, right? One of the things that matters is the generation timescale. How long does it take to get the next phenotype out? And in the pre-digital era, that's a month. In the current era, it's a minute. And that, roughly speaking, I think holds, right? But of course, there are, you know, first of all, as you mentioned, there's other timescales that matter, right? So another timescale that matters is how long it takes to get through that cognitive bottleneck, right? Certainly, some people think they can read a scientific article in 90 seconds, right? You and I would both think that's probably not the case, right? So what you might see is that you get some kind of degradation. So it isn't, for example, the idea that, you know, your rabbits are now reproducing once a minute. Instead, the rabbits have reduced in complexity to become like bacteria, right? We certainly have things in the biological world that evolve or that reproduce incredibly quickly. They also tend to be incredibly simple, right? So the human generation timescale is what, you know, 15, 20 years, depends how you push it. The bacteria timescale is minutes, and yet at the same time, the real complexity seems to be at the human scale, not the bacterial scale. So one thing that could happen when we speed these things up is that the complexity begins to drop. And in fact, it isn't that, you know, it isn't that we get new amazing phenomena. It isn't that we get 100 years of historical progress in a year. Instead, we may get no progress whatsoever, right? I think it's an open question. I think it is certainly the case that we have sped things up. And so the things that could be sped up, right? There are certain phenomena that can be sped up without any sort of degradation in their quality or any degradation in how they work. Those things, certainly, we should expect to move very quickly. But you're right that this kind of cartoon here is something that, you know, we then have to wrestle with. When you change a parameter of a system by 4 orders of magnitude, something's going to change. Let's put it that way, right? If I take your seminar of 10 people and make it into a seminar of 40,000 people, that seminar is going to fundamentally change. It's not going to be just a bigger version of the 10-person seminar. So Pia asked this question about the cognitive bottleneck. So I'm gonna make a pitch for you for a certain kind of thinking. So I suggested the possibility that we might have a science not just of cultural evolution, but of Bayesian cultural evolution. So this means I'm going to unfortunately have to talk to you briefly about Bayesian reasoning and what Bayes' rule is. For those of you, I don't know, I can certainly see the CUDAN seminar there. If you're in the seminar room, raise your hand if you have heard of Bayesian reasoning. Okay, so about half the people in the room. So Bayes' rule or Bayesian reasoning is the idea or the practice of representing states of belief, right? Representing the contents of someone's mind as a probability distribution. So this is a strange move. It was suggested by the Reverend Bayes in the 18th century. It was made real, I would say, in the 20th century, in the early 1900s, by people like Frank Ramsey, Ludwig Wittgenstein, John Maynard Keynes, in fact, since we're bringing those people up. The idea that human thought could be represented as the manipulation of probabilities, the idea that what it meant to believe something would be to attach a certain probability to that something being true. That is what Bayesian reasoning is. It's, in that sense, a model of human thinking. But it is also, bizarrely, a model of statistical inference. So, you know, this is like on Twitter, right? You see these all the time. People who do machine learning, people who try to model the world using computer algorithms also use Bayes' rule, also make this move of representing facts in the world as probability distributions. It so turns out that because computers can manipulate probability distributions very well, they can think in a way that's parallel to a model we have for human thinking. Now, is the Bayesian view of human cognition everything? No, but it so turns out that it's actually extraordinarily useful. So Bayesian reasoning, or the representation of beliefs as probability distributions, that's secretly hiding inside rational choice theory. It's secretly hiding inside most of the machinery of microeconomics. And it's also been an enormously powerful view for the cognitive sciences as well. Bayes' rule, if, you know, when I say, have people heard about Bayesian reasoning? You know, people often say yes, but I think it's often considered a little bit mysterious. I'm going to try and make it less mysterious in the next, you know, couple minutes here. If you've seen or if you've encountered Bayesian reasoning, you've often encountered it through this equation that's sitting here on the screen, a certain thing that we refer to in particular as Bayes' rule, the way of saying, oh, the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. This is often how we teach it. I think it's like not the world's greatest way to teach it. Instead, I would suggest, if you like, and I don't know how many humanities people we have in the room, you can go back and read the original paper by Reverend Bayes, right? So Bayesian reasoning emerged from the brain of a priest back in the 18th century in the United Kingdom, Reverend Bayes. That article that he wrote, actually, it's published posthumously, so somebody circulates the letter that Bayes wrote to them. What is Bayesian reasoning really fundamentally about? It is fundamentally about a certain kind of duality that people realized, a certain dual relationship between two things. So this comes up, in fact, the advance of Bayesian reasoning is the solution to, and if you look at this highlighted thing here, this is in the introduction to the article that Bayes wrote. I know of no person who has shown how to deduce the solution of the converse problem. So what is the converse problem that Bayes solved? Fundamentally, we have two things in the Bayesian picture. On the one hand, we have observations, data, things we see, behaviors and outcomes and things that people say and do. On the other hand, we have theories, which may essentially be, you can sort of think of those as stories about the way the world is. So you have things you see out there, words you hear, right? Let's say, things in a spreadsheet, but also things that you and I encounter just in our day-to-day lives. Those observations are somehow connected to, but distinct from, theories we have about the way the world is. A statistician is in the business of inference. A statistician says, okay, look, given the stuff we see, what ought we to believe? Many scientific papers basically have this structure, right? I've written a paper, the paper says, oh, we looked at the world, we saw this or that, and because we saw this or that, you should believe theory A over theory B. So that's the inference step. We often go from observations to theories. What Bayesian reasoning showed us was that to go from observations to theory, that inference is related to the converse process of going from theories to observations, that these two directions are actually intimately connected to each other. And in fact, magically, if you can solve one, then you can solve the other. This question here, given this data, what should I believe about the theory? This question, Bayesian reasoning teaches us, is in fact directly mathematically related to this question. Given this theory, what does it say the world should be like? Given observations, what should I believe? Is related to, dual to, given what I believe, what do I expect to happen? And so mathematically, we can look at it like this. The probability of certain theories given data is related to the probability of data given certain theories. The Bayesian cognitive revolution says that this duality between observations and theory, that you go from observation to theory, but you also go from theory to observation, this duality is not just something that's useful for the statisticians to understand, but it also reflects how the human brain works. So this was this kind of explosive thing that happened in the last 10, 20 years. So you see its beginnings in the 90s, early 2000s, but now this has gone completely mainstream. The idea that in order to understand human cognition, we should understand people as seeing stuff in the world, building theories about it, and also building, let's say, for example, expectations about things on the basis of the theories. Representing human beings as having in their heads probabilistic models of the world, the very kind of bargain that someone like Frank Ramsey, John Maynard Keynes made, that actually seems to be validated in the lab. So this is the cognitive this is sort of digging into the cognitive bottleneck here. It turns out that a good mathematical account of human representation forming, of what people do when they look at the world, that a good mathematical account may indeed, in fact, be a Bayesian account. So there's many different Bayesian models that we then build on data in response, right? So this is something called a hidden Markov model. Something we played with when we were modeling Wikipedia years ago, right? You have in this case here, you have a set of observations, a time series. The Bayesian model gives you a theory or an underlying representation of the time series, right? You go from data to build a theory. In response, of course, you can also go from theory to build new predictions for the data. Another example, and this is something we'll use today, I'll talk about today, is the use of topic models. Topic models are a Bayesian model of the way text works. So you have, on the one hand, observations of how people use words. What a topic model does is say, okay, I'm going to tell you a story about how those words got produced. A topic model is fundamentally a mathematical account of the way in which people make documents. So here's how it works as an account of cultural evolution. Culture begins with the human. It begins with, let's say, an individual. That person has a representation of the task at hand. Let's call that representation the theta level. That person can build on the basis of their ideas they have about the way the world works or about the way this practice works. They then produce observable behavior. So I have a representation of the ideas that our lab has come up with, right? I cannot directly transmit that representation to you. Instead, what I have to do is generate a whole bunch of words, right? That's a generation process that we can model in a Bayesian fashion. And in fact, we can even induce from the data. So given only the observable behavior, we can actually back infer mental representations. This is the amazing bargain, for example, of topic models. There's also a second step that happens in cultural evolution. It's not just that I have ideas and I generate words in order to express them, but that you, hearing my words, attempt to back infer what the hell I actually am talking about, right? So you have the inference step. I have the production step. You have the inference step, right? And of course, on the basis of those inferences you've made, so you might have a conversation about the talk I just gave, you will then in turn produce new words, right? This is the cognitive bottleneck now. It's a slightly different one from the pattern we see in biological evolution, right? In biological evolution, you have the representation level, that's the genes, right? So here are your genes. The genes make observable phenomena, the genes get copied. So you might think of it as sort of horizontal, right? You go from gene to phenotype, right? Like here's your DNA. Oh, look, Max, you're a very handsome guy, right? Okay, but Max reproduces. Max transmits his genes directly, right? So his genes produce his phenotype, but it's the genes that get transmitted directly through the replication mechanism in his cells. Culture works slightly differently. The genes now are the ideas. The genes produce the observable behavior. In order for the ideas or the representations to reproduce, they have to be inferred from the observable behavior, right? Until Elon Musk builds the neural lace, right? The only way I can get the contents of my head into the contents of your head is to talk or to write. Those are basically the two mechanisms we have. There's a little painting and a little dancing, but mostly that's what we do. We talk and we write, right? So this is the huge structural shift that happens when cultural evolution kicks off. I would say that this pathway here, the inferential step, how people go from what they see to what they believe, this is what we test in the lab all the time. This is what psychologists do a great deal. It's like, I'm going to show you a movie, tell me what you saw, right? That kind of thing. That inferential step is tested at the micro level. This generation step is fundamental to us as large-scale data scientists, right? We can see, we never get access to the people in our data, by and large. They're mostly either dead or they, for some reason, don't want to talk to us, right? We get access to the observable behavior. Our goal is to figure out, if we want to understand cultural evolution, we have to back infer the contents of people's brains. The Bayesian revolution gives us a new way to do that. The short version of what I'm saying is, if you have a Bayesian algorithm, right, if you have an inferential system, like you have your machine learning algorithm that works in a Bayesian fashion, and you train it on your data, hidden in there is an account, good or bad, who knows, is an account of the underlying representations that may be a good approximation to what's actually in someone's head. And the great example of this comes from topic modeling, right? At least in the textual case. In that case, a topic model is working at the level of text. It infers a bunch of underlying patterns that when we look at them actually seem to map pretty well onto the semantic structures of the ideas that people have. Any questions on this?
Anybody? Mark?
I would
Yes.
have, yeah. Can you hear me?
Yes, yes.
Yeah, good. So very interesting, thank you. So I have a question. I didn't ask it when you started talking about cultural evolution and you made the comparison between you have the genetic bottleneck and cognitive bottleneck. But I think it's now connected to the generation inference question also. That there's also criticism in terms of evolutionary biology in the first sense, and they have like ideas of extended evolutionary synthesis and so on, that should the idea of evolution, like even in biology, be updated? And my question is that how do you relate to the question of perhaps epigenetics plays a bigger role than it is thought, like in mainstream, that it does actually, that like DNA is not the only way to convey this information and so on in biological systems. And in regard to this generation and inference and this Bayesian idea, so it's connected in the sense that in this more epigenetic viewpoint or so on. So let's say there's like niche construction, for example, that the importance that the environment plays. So same in like, I would wonder that how it would affect what you're talking right now if you would take this more epigenetic viewpoint to cultural evolution, because I believe that, for example, context would play a lot bigger role in there, and therefore this from observable behavior, deducing the mental representation, it might be a lot more difficult. So how do you feel about it?
This is great, Mark. No, this is great. This is a great question. So let me just kind of let me amplify a little bit the remarks you're making about epigenetics and biological evolution. So that just to kind of get everyone on the same page here, right? So the idea of the genetic bottleneck, it's a simplification of how information gets transmitted from one generation to the next biologically, right? And so when people talk about epigenetics, what they're talking about there is ways in which information can somehow escape that bottleneck in some way, right? And so a great deal in the last maybe 30 years in the study of biological evolution has been looking at these alternate pathways, right? So I would say that even the most ardent epigeneticist recognizes that the bulk of information transmission happens through the genetic bottleneck, right? Most of the information from one generation to the next gets transmitted in that way, right? What's interesting is the way in which that gets perturbed by, let's say, methylation on the DNA, right? By the environment of the womb. And there are certainly ways in which culture, in which macroevolution is influenced by the larger scale context. So one way to think about this is the genetic bottleneck, information is always getting squeezed on that bottleneck, but the context that the organism finds itself in can in some ways provide modifications to how that compression works, right? If I take you, right, and I put you on Mars, your children will look pretty much identical to if they were born on Earth, right? That's because the genetic bottleneck is dominant, right? All I have to do is transmit your DNA across the, from one generation to the next to make a copy of you. Now, if we wait 100,000 years, right, the children that you produce on Mars will end up diverging from those on Earth for lots of reasons, partly due to evolution, but also partly due to shifts in the context in which that transmission's happened. Now, let's take this to the cultural evolution case. And in fact, in some ways it works sort of better for us or more easily for us, right? Look at this blue pathway here, right? This is the inferential pathway. We're asking, in other words, given what people see, what ideas do they form? Well, it is certainly the case that the ideas I form about the meaning of a text are incredibly dependent upon the presence of other texts and other contexts around that object, right? So that pathway there is conditional upon a larger scale set of expectations that a Bayesian would talk about in terms of priors, right? So no text transmits itself, right, in the absence of a larger scale set of expectations, right? In some sense, we can see this in this talk right now, right? Many of the things I'm saying, you guys are interpreting on the basis of a set of contexts you've learned, on a basis of a set of expectations, right? So if I say something that seems puzzling, right, you know that Max has good taste, so I'm probably not a moron, so that's going to influence how you back infer what's going on, right? So if I say something that sounds like, if I say something that sounds pseudoscientific, you're going to probably form an idea that is modified on the basis of the larger scale context in which that statement's occurring, right? So I think, you know, in one sense you say, what about epigenetics? I say, like, this is a story about that epigenetic transmission mechanism as well. You can think about the inferential pathway where the background representations stay stable, or you can think about that inferential pathway where those represent that background of expectations is shifting. Is that speaking, Mark, to your question? I mean, you're asking like a large. You're sort of bringing up a large scale question, which I think is a really, really good one.
Yeah. I'm not too big of a specialist in like which kind of if it should be reviewed this evolutionary, or what is the best definition. But how is your But what is your general attitude towards this view on evolution? That does it needs to be revised actually? But because the problem is that just taking it over to the analysis of culture, then there's a criticism that there's a risk that those who think that it should be revised already, they think that in cultural studies they will repeat the, so to say, old ideas that are already being now changed in biology.
So and this maybe is kind of a reflection of my old physicist heritage, right? I think these models are usefully wrong, right? It's useful to say, all right, let's focus on this particular transmission pathway, right? Let's see how far it can take us. What we find, I would say, what we find is actually it works remarkably well, but let's say it works at the 80% level. Right? Let's say that it's giving us, you know, an imperfect handle on what's going on. It's giving us a good enough of an imperfect handle that we can start to figure out or talk about the other ways in which this transmission occurs, right? We know in some sense, like the epigenetics of culture tell us that yes, there are a million different ways in which things get transmitted, quote unquote, from one generation to the next. There's a million different ways in which the ideas we have evolve over time. What this is saying is let's look at this mechanism of generation, teaching, and learning. Let's tell that story. If it breaks, then that's great. Then we can tell that story to go screw itself. If it works, or the extent to which it works, tells us what we have to then put into the mix to get it working better, right? You know, it's of course possible that this is leading us entirely astray. But if we want to make a, you know, like you could think of this as, I would say, like sort of like a first pass. We're like Crick and Watson here, right? We know that somehow information is getting transmitted from generation to generation. Crick and Watson discovered DNA. I think the Bayesian perspective on cultural evolution is equivalent to the discovery of DNA. Is DNA everything? No, absolutely not. But the understanding of how DNA works led us to what we think of today as the neo-Darwinian synthesis. That was the beginning of rigorous quantitative evolutionary biology. And I think that's the same potential we have here for the Bayesian cognitive perspective. It's a good beginning for the thing we all know is extraordinarily hard, which is figuring out how information passes from one to the next.
So Pia has a question or a comment. I also have like, there's like we're going over a threshold where something is like cooking up. I think I need to react to, but Pia, yeah.
Go for it.
Yes, yes. Actually, I really appreciated Mark's question because, of course, context is also, as you said, we all bring into this conversation our own ideas of how the world is built and these theories, and so context is really important also in cultural evolution, like or cultural analytics. It's not only that. These cultural objects are like this text on your page. They are not same texts when they are reflected in different contexts, in different time by different people, and this is of course something that you also recognize. But I'm just wondering that how much emphasis should here be put on the context of this inference against this context of the generation.
Right. So, you know, one of the nice things about the Bayesian perspective is that it gives us a way to mathematically model the role of context over and above the role of inference, right? So what the Bayesian will say is every inferential step happens within a particular context, right? The lessons that I derive from a text, the theory that I induce from the data depends upon the background of expectations I have about that data. So for a Bayesian, those are called priors, right? So the priors, in some sense, encode the context in which the inferential step happens, right? So this system gives us the possibility, or gives us a handle potentially on how the contextual background is shifting for people, or the ways in which we may need to say, okay, look, we're looking at how people behave on Reddit, right? We're looking at how they're doing inference, but it turns out that some of these people are doing this inference under a different context than others. You can see this a little bit if we get to it, which is fine if we don't, right? If we get to it, we can see this happening with people like newcomers to a system versus old timers. So someone who's been engaged in a cultural practice for a long time has, as a Bayesian would say, more finely tuned priors. They have a certain more definitive sense of the context in which any practice is happening. So, but a newcomer doesn't. Personally, we haven't looked at the shifting of context too much. We've generally assumed in our models or in our inferences from data, we've tended to assume a fixed context that everybody shares. We try and figure out what that context is and works from there. But I would say that the Bayesian cognitive perspective gives you a way to talk about those larger questions in a new way.
Okay, nice. So maybe I can try to summarize a little bit. There is, because there's lots of aspects which actually feed into a major issue or something, a kind of, let's say, I wouldn't say dissonance, but there is a kind of, there's an open space where some progress could be made, I think. So one thing is, you talk about, you casually at some point said, you used the word kinds of variation, and kinds of variation obviously are sort of, you know, they come with kinds of selection, right? Like natural selection versus Darwin pigeon breeding, which is obviously sort of artificial selection. And the kinds of variation we assume are typically not always the same. And this is very much more true in culture than it is true in nature, maybe, right? So the question is like, what is the shape of the variation? Is it Gaussian? Is it random? In another way, is there some targetedness going on and stuff like that? So that's one thing which I think is important, because if you look at the cultural evolution crowd, which if you go to the annual conference that is actually now biannual of the Cultural Evolution Society, you find about 50% evolutionary psychologists, and the other 50% are very, very closely rooted in a kind of biological model of evolution. And then brings us to this point of what Mark is actually talking about. And I'm also very thankful about that question, because it actually feeds into two things. One is, beyond actually evolution with the, or transmission with the genes, transmission with epigenetics. There's a bunch of other forms of ways we can imagine there is transmission going on. And in culture in particular, not only do we have you not only have this kind of cognitive process, but we produce stuff, and that stuff influences other stuff just by being present, right? Like, for whatever reason, you may think it to be cool to drive your car too fast and the car hits the bridge and leaves some trace mark, which then disorients somebody else to also hit the bridge, which is not, it's not going through a head, but there's still some influence going on from one event to the other. Yeah. And we have actually systems, including in biology, where you have similar things going on. Like, for example, the microbiome has now been shown to have similar function in all our intestines, even though the composition of species in all our intestines may be fundamentally very, very different and have a large variance. Now, the other thing is, we not only have texts, and I found this quite funny. You say, we talk and we write, and sometimes we do a little painting and we do a little dancing. Actually, there's, artists paint mostly and write and talk less. Dancers dance and do not paint, do not write text, and do not talk, maybe. And so the key question is it really, can we really start from biology and say, okay, the genome is the dominant thing, the genetic bottleneck is the dominant thing. We can do sequence alignment, we can look at character strings, let's look at texts, let's treat it the same way as a first approximation even. So we have topic models, which is like basically bag of words, like, Craig Venter fishing out a bunch of genome things in little shovels out of the ocean. Or let's be a little bit more specific and say, okay, we really have the genes of particular individuals, and then we align them and do sequence alignment. And then there's this other thing, which you also mentioned, which is Markov chains. Now, Markov chains have states, right? And so the states are discrete, just like the character strings are discrete. While in the interaction in the real world, there may be other things going on. There may be quasi-continuous functions going on. There may be quasi-continuous interactions going on, like, in a fluid or something like that. And so I don't want to take it too far, but there is the critique of the Bayesian statistics methods that Nassim Taleb actually last week sort of like builds a larger kind of argument about, is that if we do that, if you look at the past as a probability distribution that allows us to predict a future state, then we don't take into account that we're actually having one process that goes from the past into the future. Like, the current probability of Joe Biden to be elected has to be seen in the context of the continuous function that is underlying that, and that may tell you still have no decision beyond 50-50 if you will make it or not. And so the key question is, how can we, beyond doing things that are inspired by biology, find these things that are different in culture? For example, because they're continuous, because they do not work in states, because they do not come in nice little things that we can sequence align, things that we can draw and node and links. So how do we actually get beyond that kind of state? And I think that is a crucial question, because so many things in culture behave on that kind of level, so they cannot be touched. And that always leads to the kind of critique if we sort of make it too simple. Does it make sense? It's an attempt of a summary, and also a question that basically maybe I invite you to defend your approach in choosing a Bayesian kind of paradigm that works with text as sort of the central way to understand cultural evolution.
Right. I mean, this is great. And I think, Max, you and I might disagree on some really basic things, which is always, of course, very productive to do. As a physicist, I'm used to being irritating in every discipline that I show up. But fortunately, I was given very high levels of self-esteem, so that I think the problem is everyone else, not me, right? But I think so it is very much the case, right, that, you know, what I'm doing here is bringing a strong picture of how humans work and how culture works. And, you know, the case I made to Mark was that perhaps this is a good first approximation, but of course it may not work, right? Ways in which this can fail is if, you know, the primary means by which we maintain culture, by which we do things, is not talking and writing, right? I think it's, you know, if you look at, you know, you sort of take a census, right? You say, what's in the air? What, you know, how much information transmission is happening by this thing versus that thing? My bargain is that the majority of how culture progresses from one stage to the next is through talking. We talk to each other, that we write to each other. It is true, you know, I mean, I have eyebrows, like I could do my little eyebrow dance, right? But, you know, the claim is, in fact, that if I got on this thing and muted myself and did the eyebrow dance, I wouldn't really transmit that much, right? I can certainly modify, right? I can, you know, attempt to convey my excitement about the Bayesian revolution, right, by sort of throwing my hands around. But you know, by and large, the way in which I am getting stuff into your head is talking. And you know, 5,000 years ago, it was a big moment. We started writing as well, right? And writing has now come increasingly to dominate how we interact with each other. In the social media era, it's extraordinary. You know, it's extraordinary, right? Anybody over, you know, under the age of 30, you know, they can't even use a telephone, right? Because they're so used to texting, right? So, you know, I think to a large extent, you know, I'm making a strong claim, right? I'm making a claim that certain kinds of behaviors, talking and writing, right? And in particular, word generation is the primary means by which, you know, this Geist does its thing. You know, it's certainly, you know, if you're an economist, you care about prices, right? If you're you know, a biologist, you care probably about the carbon cycle, right? For us, as, you know, people studying culture, I would say a major pathway, if not the major pathway, is words. That's what we do. Words are extraordinary, right? So, you know, you guys can have a conversation in German or Estonian or Dutch about Bayesian reasoning. You can actually transmit the same information, right? That mental representation theta level, you can actually get that going in any language you want, right? I don't have to say, if I say, who here knows about Bayesian reasoning stuff? I don't care what language you've learned it in. Words turn out to be extraordinarily effective ways, repurposable ways to transmit this underlying, what I'm calling the genetic code, which is ideas. So, you know, you know, another way to say this is, I'm saying, look, what's the fundamental constitution of spirit? It's this representational level. Now, the extent to which representation is a good story about culture, let's put that to one side, right? That's the kind of, representation is a philosophically fraught concept. But what I'm saying is that representations evolve. The practical mechanism, right? Like if you just count up how those representations are transmitting themselves, because we can't actually mind meld, right? Those things are latent in the world. The primary ways by which that happens is through talking and writing. Now, I get into debates with friends of mine who are Marxists, right? And they say, no, like, you know, all these words, that's just superstructure, right? That's you know, that's just fluff on top of an underlying material process. And in fact, what's governing the evolution of representations is, you know, money or energy or CO2, whatever it is. I'm unapologetically idealist about this, right? I think that ideas are driven, like ideas are the causal objects here, right? Ideas are generated and they're inferred. So, you know, you say, okay, well, what about the kind of more continuous aspects of life, right? What about the things that you can't discretize in the way we discretize words, right? Another way to say this is, what would be lost in this talk? What would affect the evolution of this talk if all you had was the closed caption stuff on the bottom of the screen? So you couldn't see me, you couldn't hear me. All you saw was the transcript of what I was saying. Absolutely, that would alter the development of the ideas, right? I would say not too much. If you're deaf, if you're blind, you can basically participate in culture the way somebody without, the way somebody who can see or can hear can do. I would say that like, there are certainly huge differences, but those differences, I think it's easy for us to overestimate them and to underestimate the commonality of just one process. Now, like, you're an art historian, right? So I'm basically saying, hey, jump off a bridge. It's absolutely the case that visual representations matter. I would say that, like, these, and like dance and ballet, right? These are wonderful. I think of some of these as sort of almost like sort of separate universes, right? What makes, ballet, like anyone can read a newspaper, right? Anybody can have a conversation. It takes a little bit of training to learn how to quote unquote read a painting, right? I would say what we're doing there, when we have, the reason we have, let's say, art history, the reason you and I might think of, oh, that person has good taste or they have a really good sense of art. What I think that, to me, what that means is that they've learned an inferential mechanism, right? They have a good blue pathway on the screen here. I would say those things sit on top of an underlying cultural practice, right? Those things are sort of, those are kind of elite activities that sit on top of the sort of the 99% of culture, which, I mean, look, Christ, I sound like a crazy person saying this, but like the 99% of culture is talking and writing.
Thank you very much. This is really interesting. So I do think that there is really some complementarity going on, where we might expect in the near future probably rather different results, but they won't contradict each other. And I do think there's a lot of complementarity. Obviously, I could defend my own discipline of art history right now.
Yeah.
But let me just quote Leopold Stokowski, who said, "Music is more than black marks on white paper." The same is true for art. And so there's a lot to contribute by looking at figures and pictures and paintings and listening to sounds more than the text, right? Obviously, one can approach it that way, but it's not all. And I said this is a really interesting kind of thing, which actually this is something I should mention to the audience. Like, one of the moment when I decided to I really wanted to talk to Simon early in this project was when you tweeted your bookshelf, and I figured out, oh, you do cultural analytics. Actually, spoiler alert, and advertising. You're gonna do a cultural analytics summer school in the style of a Santa Fe summer school, which is amazing, and everybody should apply.
Good. Yes, absolutely. Yeah.
So the interesting thing about that bookshelf was I expected a stronger overlap, but my sort of like core bookshelf and your core bookshelf have like 5 books overlap.
Which is interesting.
And then I invited you to give the talk and also said you should come over for a couple of days, because I'm pretty sure we could talk for 5 days without interruption, without running out of stuff that we mutually don't know about what we think about the same 3 words, cultural data analytics. So that is something which I think is quite interesting. So Daniel lifts his hand, and I want to give a word to him, and then Pia has something to say.
Yeah.
Yes, thank you. Can you hear me?
Yes, yep, I can hear you.
Okay.
Yeah.
Thank you for a great talk. It's very stimulating. I have to say, in the interest of time, that I think what you call a strong claim, I don't find as strong as you. I think it's and I also don't think it's necessarily a first approximation to this problem. Kind of piggybacking on Max's point earlier, it seems to me that there is there is an overemphasis on 2 things, no? On communication, transmission through talking and literary texts. So it's like either talking and writing or eyebrows. And I thought you have great eyebrows, and maybe this is the reason why that springs to mind, no? But it also, I think the counterpoint to that is that most of the internet, for example, most of the artifacts that, cultural artifacts, or what we understand as cultural artifacts going online at the moment, are images. and they are interpreted as images, and many times they are interpreted in ways that are prior to language. In many ways, you could also have the opposite argument that what the elitist activity is the linguistic activity, is learning to read a newspaper. Whereas the very first thing many of us learn to do, we learn to see before we learn to talk and before we learn to write even. No? So there is, I find in that part of the argument, I'm far less convinced. I do really like the base kind of inflected Scottish Enlightenment element of it, but I'm far less convinced about the emphasis on verbal communication and transmission as the core elements of cultural evolution, if that makes any sense. So that's just that's it. I really don't have much more of a question. It's more.
No, that's great. So let's take these two thoughts in turn, right? I absolutely agree. I mean, the verbal facility emerges late, depending on the child, right? It emerges, let's say at the latest around 3 years old. I mean, depending, right? It emerges roughly at the same time that human performance diverges from primates, from the other primates, right? So roughly at the same time that the characteristic phenomena of humanness emerge, that is roughly the same time at which we as a symbolic species start to get going, at roughly the same developmental timescale, 3 years, at which the child becomes good at language. So in one sense, I completely agree, right? We have an ancient evolutionary heritage that is, perhaps visual, auditory, but the emergence of us as symbol users, right, happens, I would say, first visually, let's say in schematic drawings, but primarily language in language, right? So, Max asked at the beginning, right, what makes, can we have a science of humanness as opposed to animalness? I would say part of that science has to be oriented around us as symbolic users or symbol users. And the primary mechanism of symbol use, I would say still, is verbal. Now take, for example, the memes, right? Like the idea that what happens on the internet is primarily visual. People have said this for a long time, right? We're still waiting for this transition to visual culture. Most of the memes that I see online involve people taking a picture, right, and writing on it, putting words on it, right? So it's like, like the guy checking out the other girl meme, right? It's like, like cultural evolution, like looks away from his girlfriend biology and looks over to Bayes, right? We often, the way we use images, right, is as ways to, and this is something that I think Mark and Pia are thinking about, right? The way we use images is to predispose or provide context for the words, right? If anyone counts as a post-verbal president, it's Donald Trump. And yet at the same time, Trump is somebody who works entirely with words. He works with nicknames. He works with slogans. There is, to a certain extent, a visual language there, a visual syntax, which is super interesting. But, he has a red hat. What's crucial about the red hat is the words on the hat. So I think it's, and I'm making a strong case here, in part, to give Max something to chew on, right? But to a certain extent, even when images play a role in culture, very often they provide a kind of contextual role for talking, right? They provide a set of ways to predispose one to interpret words in one way versus another.
But okay, so just a quick follow-up on that. Even if that was the case, and say we're kind of willing to kind of meet you somewhere closer to your own position, what happens to go back to earlier in your presentation, to the definition or the ontology of the written word? Aren't written words forms of images that we see? The shapes of the letters and the shapes of the are still in many ways difficult to disentangle from our visual words, no? From visuality in that sense. So even if we agree that the letters on the Make America Great Again hat are the most important thing, which, you know, I'm not necessarily conceding that that's the case, but even if we do, then we have to also acknowledge that in order for us to read these letters, we have to have, you know, the what you call symbolic manipulation also necessarily needs to be built upon the possibility of seeing the letters as images, the letters as images and the words as things, visual representations. So much so that if it's on a different language and the shape looks different, then there is a correspond, you know, what you call communication and the transmission of communication will be hindered. No,
I think that's right. I mean, this is, you know, Max said, what about the continuous as opposed to the discrete, right? So I'm just going back and forth. I don't know. I mean, look, I'm not actually a savage, right? Guys, I actually have some class here. I do love images, and I go to the art museum all the time, right? But like, so like, take like, okay, this is a font called Gill Sans. So Gill Sans, it's in the old Apple version. So Gill, it's really, the story here is fascinating. So Eric Gill was a designer, typographer in the United Kingdom. This font, actually, you will see, if you go to London, you'll see it all over the place. It's in a lot of the official signage. It's on British Rail. It's on, you'll see it in Heathrow Airport. One of the great things, Gill himself was so fucked up. This guy was like a total maniac. He was an artist, right? He screwed animals. The guy was really weird. So to me, it's kind of amusing that like the official typeface of the British Empire at this point was developed by like not even a pedophile, like a guy who had sex with animals. So Gill was just a nutcase, right? So there's a huge amount here. It's a gorgeous font. It's a beautiful object, right? There is, and it's also something that exists on the continuous level, right? So if we can zoom in here, right, and look, this is as much as Apple lets me do it, right? We can zoom in and see the kind of the gorgeousness of what's going on, right? And of course, like this is really different from like, let's go to, this is just, I hate this font. Like this is awful. Like there's nothing good about this font, right? So there's an enormous amount there. Now, and of course, having a sensitivity to that is part of what we do if you want to study the visual culture, right, to understand that. Yet at the same time, you're really good at discretizing, meaning taking this X here and considering it equivalent to this X, and considering equivalent to this X, right, and to, God forbid, Comic Sans, right? Like you're able, right, this enormous continuous space, right? You do this all the time.
You're right. You're right. You're right, but you're not. So yes, we all accept it as an X, but you just said, God forbid, Comic Sans.
Yep.
They're not the same X. They're not.
Exactly. So right.
One X is forbidden by God.
Yeah, right. So here's another way to say it, and this is this is I think where the compromise comes from, and I just have to make it a nice font again. Sorry. This is where the compromise comes for us, right? Is what is happening? Obviously, if I gave this talk with Comic Sans, right, this would not go well for me, right? That would very much influence the ideas in which you formed, right? So what is the impact, right? Is it Comic Sans versus Gill Sans? Which, by the way, that's a discrete shift there, right? To what extent are the continuous aspects of, let's say, the letter forms in the same way? What are the continuous aspects of the image? How much do those impact or influence transmission? And then what are the ways in which they do? So I would say if I gave a job talk and I did this in Gill Sans versus Times New Roman, I think there would be pretty much, they'd be like, guy looks pretty competent, right? I do it in Gill Sans, they're like, oh, he probably thinks he's like Steve Jobs or something, like he'll probably be a pain in a faculty meeting. But like, there'll be some judgments that are made. I do it in Comic Sans, they're like, oh, what is this kook, right? Those are still, I would say, discrete judgments. And I'm not sure that it's possible to really, for the continuity of life, to really leave a lasting impact on how transmission works, right? It's true that there are sort of non-verbal aspects to this talk, right? My claim is that the verbal aspects are primary. it is possible, like if I did this in Comic Sans, yes, this would radically influence the inferential step, right? You'd probably judge me as less competent, right? Yet at the same time, even there, right, it's like a discrete chunk of metadata, right? If I wanted to describe, or I wanted to model how things go, I probably just need to keep track of the visual of the font name. That would probably be enough. And maybe worst case is like the fraction of type, text in each font. So I would love, I mean, look, go for it, right? And Max is going to go for it, which is look for the impact of the continuous on culture. I tend to see us as, symbolic species. We are constant regularizers. We're constantly pushing ourselves back onto a smaller, discrete set of options. It's the, I see us not, let's say, not as continuous creatures, but as combinatory creatures. We love alphabets, right? We love regularizing around a small set of symbols that we combine. But of course, that's not what the visual arts do.
So I would like to, before I have to disrupt the continuous flow of images and sound by making this a discrete event, we have another 3 minutes and there's 2 hands raised. So Pia again, and then Daniel again, and then whoever, if we still have time, there's probably time for one more question. So whoever's ready.
I'd be delighted. Yeah, absolutely.
Pia goes first.
Thank you, Simon. So this is very exciting discussion. But I would really like to go back, especially based, Simon, on how you defended yourself now against these attacks from the audiovisual people. Since we have to go back to the meaning making. And meaning making takes place in a human mind. So once again, I'm saying that studying culture cannot happen independently of understanding how mind works, and that brings us back to the cognitive bottleneck. But this is just a note. No, short time.
No, I think that's right, and I mean this is the real challenge. Is hidden in this inferential step is a theory of the mind. Right? And so what the Bayesian perspective allows us to do is to get clear on what the theories we have are, right? What you put into the model at that point includes an account of what the human is paying attention to, the signals that they use. And in a sense, to be good at Bayesian cognitive evolution is to be a good artist at the mental representation level, right? And so it looks like you guys have an amazing ability to not want to talk about Nazis, because usually everyone wants to talk about the Nazis at the end of this talk. But so we're not going to get to it, right? But in order to understand, if you try to understand, let's say, conspiracy theorists from the point of view of the Bayesian perspective, what you're really doing now is saying, okay, what is the representational framework that I want to put in here that will best account for what's going on, right? Do I put in emotions? Do I put in personal experiences? Do I put in, a representation of pseudoscientific concepts? So I think what it means to be good at doing this is to be good at the mental representation level, which is fundamentally to be good at telling a story precisely of how the mind works, right? What we've neglected, I think, in cultural evolution, we focus so much on the macro level, on the sort of indicators, as the economists would say. We've lost sight of the importance of telling a good story at the micro level about the human mind. So I know we're running short on time, so we should there was another question. Thank you, Pia, for your question.
Actually, yeah, thank you very much. So we're actually out of time, and I sort of find it very nice how productive we derailed from the original objective of the talk. But which we, at some point, this would be something you will publish anyway, and you will probably present elsewhere. But this was a unique discussion, in that sense, a discrete object that will remain. And so I thank you a lot for this. I already get like side channel messages how awesome this is, and it is. I thank you very much, and I would love to continue the discussion. And I think the questions, how far this model can, like Bayesian modeling, Markov chains, topic models with text can go, how far we can find other ways to explain culture. And what I think what's really important, what Pia just said, that meaning making happens in the mind. is sort of something we shouldn't forget. We basically talked for 2 hours about the communication channels of text and images, which is not what's happening in the mind itself, or arguably what's not happening in the mind itself. And so this could be, as Kassira said, more generally a pure mathematical space of thinking, which may be neither text nor image nor visual, not auditory, but something else. And the question is obviously, how does this mapping back and forth work? Yeah, I'm not sure about Hegel though. And so that's another conversation.
I have drunk from the cup, Max.
Yeah, exactly.
It's obviously, I mean, Max, thank you very much for this invitation. It's hugely flattering. You know, when all this craziness is over, it would be a delight to come out and see you guys. I mean, I should say, I mean, I don't know, you know, who people are in the seminar room there, but it's very exciting for us, just, you know, people working in this space to see, you know, Estonia doing this, University of Tallinn doing this. I was thrilled that they got you. This is great, right? But you know, having people together working on these problems, debating these problems, it's just rare that I get to talk at this level, to go back and forth with you and with, you know, Mark and Pia, Daniel, Dennis. This is wonderful. It's not a chance we often get, because we're usually, and I'm sure you know that you have the same feeling, we're usually just even fighting to get heard, right? So it's great to actually debate these things, as opposed to simply have to, you know, make a case for the very existence of what we're doing. So you guys are lucky to have Max out there. It's great, and I hope I'll be able to see you guys in person when we're not going to kill each other by touching. So
Nice.
God bless. Good luck. Have a lovely evening. And thanks for waking me up. This is wonderful. Have a good day, everybody.
Thank you very much. We're going to update the webpage so you find out who we are.
Excellent. Good job. Good job. Bye-bye. Thank you, everybody.
Bye-bye.